Hello again. In this very brief lecture, I'm going to cover electrolytes. Electrolytes and acids, strong acids, weak acids, bases, which can either be strong or weak, are very integrally tied to electrolytes. And so you're wondering why the OpenStax chemistry textbook, chapter 11, section 2, is like 2 pages long, and they kind of throw it out there. Well, they introduce it right after they talk about solutions and how things dissolve in water, just so that you could have an idea later on when we talk about acids and bases about the electrical content of these solutions. Okay, so let me just tell you what you need to know in this part of the class. You need to know there are 3 types of solutions. We've got electrolytes, or strong electrolytes, we sometimes call them. We have non-electrolytes, and we have weak electrolytes. Okay, now strong electrolytes strongly conduct electricity. I'll show you what that means later on. But basically, they contain aqueous ions. So they're written with a reaction arrow. And so, for example, if you have sodium chloride, barium chloride, sodium nitrate, anything that's an ionic compound that's soluble in water, we just draw the solid form dissolving to form the aqueous ions. And because of that electrically charged ion mixture in the homogeneous solution, it can strongly conduct electricity. So we say aqueous sodium chloride is a strong electrolyte. That's basically what keeps your heart beating. You have different sodium ions and potassium ions in there that transmit the electrical potential of your cardiac muscles and nerve signals in your brain and everything else. Okay, electricity flows through ions. Now, what about non-electrolyte? Non-electrolytes do not conduct electricity. I have a demonstration of that later in this video you'll be interested to see. And these contain just molecules, okay, aqueous molecules. Now, they're written with a reaction arrow. For example, we've seen sucrose, which is table sugar, how it dissolves in water to form just aqueous molecules. If you haven't watched it already, take a look at my dissolution lecture so you can see how covalent molecules or molecular molecules, they all stay as one unit. They don't break apart to form ions, and they're just AQ, okay? So we say sugar water is a non-electrolyte. It's not going to conduct electricity. So if you have the flu and you can't hold down any fluids and you have to go to the ER and they run an IV, they're going to put 2 things in the IV bag. They're going to put sugar, okay, because we need energy from sugar, right? And they're also going to put sodium chloride or potassium chloride or other electrolytes in the IV bag because you need that salt content for proper physiological function. All right, now conductivity tests, pretty wild and crazy. I'm going to show you what this looks like. But basically, you do a conductivity test, all right, to decide in the lab experimentally if a solution is a non-electrolyte, strong electrolyte, or a weak electrolyte based on the conductivity, okay? Let me show you what that looks like now.
This is our light bulb, and this is the plug. Now, if I plug this in, this won't light up. If I connect these 2 wires together, it will light up. And so if you place this into a solution that's a strong electrolyte, electricity will travel between the 2 wires through the solution and it will light up very brightly. If you place it into a non-electrolyte, no electricity can conduct between these 2 different wires in solution, so it will be off. And if you place this into a weak electrolyte, it should dimly light up. I will demonstrate 2 solutions, and then I will just read off the data for the rest of the solutions here, okay? So we're gonna do sodium chloride and then sucrose, and then I'll unplug this thing, and then we'll go from there. All right, so this is very dangerous because I could electrocute myself if I touch these wires. So usually I just hold the thing like this. All right, so this is 0.1 molar sodium chloride, NaCl. So we'll put this in here. It's like scary. Okay. All right. It's like throwing a toaster in your bathtub. Okay, that lit up. That's what I call bright. Here is 0.1 molar sucrose, which is table sugar. So let's put this in here. and that's what we call off, okay? So that first one was on, this one's off.
All right, I gotta tell you, that's pretty much the scariest things I do here in the lab. But let me now talk about weak electrolytes. Now, weak electrolytes are integrally tied to weak bases and weak acids, and that's a whole extremely large topic later on in this course. So let me just give you two examples. I've asked you to memorize ammonia, and I've asked you to memorize acetic acid, and so let's just look at those two. Let's look at one weak acid and one weak base and just see how they work. All right? So first of all, weak electrolytes are going to weakly conduct electricity because when these substances dissolve into water, they either react with water or produce mostly molecules, but some aqueous ions. And since you just have a little bit of aqueous ions, they're slightly conductive, all right? We write them with the dynamic equilibrium arrow, and it's very important to do that. Now, you have very few ions in solution, as I mentioned, so that's why it conducts electricity just a little bit, okay? And we call these weak electrolytes, all right? Let's look at one example that I would like you to remember. So memorize or write this equation down in your notes as you're taking notes here. We've got acetic acid, which has that crazy formula there, HC2H3O2. When that dissolves into water, it actually reacts with the water molecules to produce minor, very small amounts of acetate ion and hydronium ion, okay? This might be, in a typical weak acid solution, 1 to 5% of the mixture, okay? So you've got 99% or 95% mostly associated molecules, okay? So in solution, it's mostly acetic acid, but you've got a little acetate ion in there. All weak acids, as we'll see later on in the class, like acetic acid here, are weak electrolytes. Now, I promised you ammonia. Example 2 is ammonia. We've memorized this formula as NH3. All right, so you want to write this equation down or just memorize it if it looks familiar. Ammonia reacts with water to form ammonium ion and hydroxide ion. We've got that chemistry joke. What does a panda get when it drinks ammonia? It gets pandemonium. All right, so you've got the ammonium ion NH4+, you've got the ammonia molecule, which is neutral, NH3. And so this reaction is a reaction with water. And so in solution, we've got mostly ammonia. I forget the percentages, but more than 90% of a neutral ammonia and neutral water. Neutral substances do not conduct electricity, right? But you've got a very small percentage of ammonium ion and hydroxide ion, which have charge. And when they're in water, they can conduct electricity. All right? All weak bases, as we will see later on in the course, are weak electrolytes. And we always use that equilibrium arrow, the dynamic equilibrium arrow, to write these chemical reactions. Thanks for watching. Please like, please subscribe. Have a great day.